Hello, my name is Dmitry Arefiev and I am a developer of FireDAC Data Access Library. And today I'd like to talk about a local SQL capability of the library. This capability can be used to access heterogeneous data sources. Heterogeneous means any various childs inherited from T data set. So let's discuss the agenda of my webinar. First, I'd like to dwell upon briefly the FireDAC as a library. Then I'll discuss local SQL in short, and then I'll discuss the application with local SQL. I mean how to develop applications with local SQL mechanism and how to configure such applications and the local SQL access. Then I'll show how SQL commands are mapped to SQL set API calls. And at the end I'll discuss how namespaces and schemas are controlled from the viewpoint of local SQL, and I'll show some new capabilities introduced in this mechanism. As you possibly know, in March 2013, Embacadero acquired any DAC technology from DA Soft Technologies company and then rebranded it to FireDAC. And then the technology was introduced as a part of Delphi, RAD Studio and C++ Builder, and is a part of this set of technologies. It is so since XE4 and in XE5 it's also available. FireDAC is an universal data access library that unifies the communication with different DBMS platforms. In addition, FireDAC proposes some unique capabilities we are going to discuss, like local SQL. FireDAC provides high-speed native data access, and it is a cross-platform or multi-platform libraries available in applications for Windows, Mac OS, iOS and Android. I can say that FireDAC is now ready for any new platforms. For example, if Linux, yes, we'll be ready to port FireDAC to Linux, and FireDAC is available both in Delphi and C++ Builder. And let me please say some words about the DBMS platforms. Of course, first, these are enterprise database platforms like Oracle or SQL Server. Then we have workgroup databases like PostgreSQL, Interbase, Firebird, MySQL. Local SQL engines like SQLite or Microsoft Access, if you need to have a local DB access. And finally, it can be used to access DataSnap servers. Now let's start from considering what local SQL is indeed. Local SQL mechanism in FireDAC makes possible to execute commands on arbitrary data sets. So you can take any derivative class from T data set and execute a command on it. Of course, you can take FireDAC dataset or any other dataset component and run SQL command. If you want to run or execute some SQL command, you need first to register the data source or dataset source. For this, there is a special component TFD LocalSQL. This capability is based on SQLite engine, namely a virtual table or vtable API. This API is quite similar to Oracle heterogeneous services or SQL links in Microsoft SQL Server. SQLite is an embedded database, so it is built together with the executable, so it allows to use these mechanisms with data sets. The dialect of SQLite is quite rich and quite powerful. So local SQL mechanism in FireDAC supports the same set of commands like select, insert, update, delete or replace. Specifically speaking, select is also quite rich, so you can use nested queries or inline queries. In addition, a large number of functions are also available in local SQL. Unfortunately, DDL commands are not supported in local SQL, like create, alter, drop. So you have no chance to create or alter or drop table using the local SQL dialect. Instead of using such commands, you will have to use your data set components properly, but we'll discuss this later. Transactions are also supported and at the level of data sets, and all the transactional commands are converted into the API of the dataset. The simplest example is the save point call. Before the transaction, save point is saved, and if transaction is successful, nothing special will happen. But in the unsuccessful transaction, the save point will be restored. So the dataset will have the state at the primary save point before the transaction. You can also see PS start transactions or PS end transaction. They are a part of so-called provider interface. It is a special type of interface and supported by a number of data sets. So the transactions are mapped or translated into the cached updates. And now let's consider how one can apply the local SQL in real applications. First are heterogeneous queries. For example, you need to make queries for data sets, and these data sets retrieve data from different DBMS platforms. One can say that all these can be done using the built-in services like Microsoft linked servers or Oracle heterogeneous services, but in our case it's a good alternative and effective approach when you can more clear control the queries. Another good way of using local SQL in FireDAC is the DB in memory, when you can upload the database fully in memory using the TFD memtable components and then work with them. of course using the SQL commands. Another subtype of the previous case is the database in CSV files. CSV is a format of data storage like comma-separated values. So you can load the data using TFD, DMM table components from CSV files into memory, and then use the local SQL the same way. The next capability is to extend offline mode of your application. Your application, which uses FireDAC, can work in disconnected mode when the connection is stopped and data in datasets are still in memory. You can continue using SQL commands and execute them even in offline mode. Another good idea is also to extend the data snap client. For example, if you are using stored procedures to retrieve data from database via application server, you can use the TFD stored procs for stored procedures, and then primarily having retrieved the data, you can then process them further using the local SQL commands. One more good idea is to use the local SQL capabilities of FireDAC for simplified migration. For example, you are restructuring your application to migrate to FireDAC components. So you are using the basic capabilities to retrieve data and then process them using the local SQL. This approach will make your migration more easy, as the logic is controlled within your application. Okay, now let's start doing a simple local SQL application, and let's consider how should we configure the components. As I have already said, the FireDAC uses the SQLite driver for local SQL engine. So the first thing you need to have is the SQLite connection in your application. There we have two options. First is the conventional, traditional connection, or when your application is connected to a database in a file. And in another case, you can use the database in memory. I do recommend the second approach when you have a database in memory, because you needn't separate standalone database file, and you can more easily configure and connect and use your local SQL capabilities. It is really easy and clear. You can use the TFD connection component in FireDAC and set the driver name to SQLite value, and that's all. You needn't to set some other connection parameters. All you need is the driver name. Then we need to add two more components, and these components are always necessary to add to a FireDAC application. If you did some FireDAC application, it's not in use. So you should add the Fizz SQLite driver link component and GUI cursor like component to the form. Finally, we will add the TFD local SQL component to the form and bind it to the connection component. Once again, the database will be in memory. Then we need to add and register as many dataset components as we need, and FireDAC dataset components have local SQL property, and this property should be linked to our local SQL component that we added previously. Then we need to activate the connection and the local SQL engine itself. And now we are ready to use TFD table or TFD query components and compose, write and execute the local SQL command as we need. Now it's time to see how all these happen in real life, not in theory. So let's start from an empty or blank application, a simple form, and I'm setting two traditional components like FD GUI wait cursor and another FireSQL light driver link, as we discussed previously. Then FD connection, and I'm selecting the SQLite driver for it. No other special parameters are necessary. So we are setting the FD local SQL components to use the engine. Then we'll link it with the SQLite connection. Then let's make a very simple database in memory using the FD mem table component, and then we will compose a query to it. And now I am linking the FD mem table component to the FD local SQL. So this dataset is now registered as the component for local SQL engine. And now I am using the TFD query component to execute queries. I link it to the connection, and then we can work as we usually do, using data source component and dbgrid. And then for onCreate event, I'll use some code I prepared previously. Just copy paste. What am I doing? First I'm defining the structure of the table, and I'm defining the key field and activate this table in memory. Then I'm adding 5 records to this table. Then I'm activating the connection, and then I'm activating the SQLite, the local SQL engine, and I can execute the query from the code. I'm using the name of the component as the table name for the query, as it is registered, and in our case it's a simple but quite good SQL query. But of course, in more complicated case, you can execute joins for multiple data sets, or execute complicated queries with where statement, etc. Something went something is not so good. Let me please fix. Let me check the links between components. Not so good. Okay, yes, that's a typical mistake. So the data are retrieved from table in memory, but we need to show the results of the query, so the link should be changed for FD query. Now we see the results of the query where data are sorted using name value. This was a very simple Hello World-like application demonstrating how to use FireDAC components and local SQL engine. And now I'd like to stress and consider in details how SQL commands are mapped to dataset API. First three commands are trivial, like insert, update, delete. Insert is mapped to append and post. Update correspondingly locate, edit, post, and delete do the same, like locate and then delete. I must say that these commands and this technique need the presence of key fields in the data set in order to locate the record properly. If there is no such key fields, all the field values are used to find a particular record to execute these operations. Let's consider order by expression. It is translated or mapped into index field names if dataset supports such a functionality. Otherwise, the capabilities of SQLite engine are used. Something similar is for where it is translated into set range functionality or to the use of filter property, or if they are not supported by means of SQLite's built-in internal capabilities. Save points. If supported, it's okay. If this property is not supported, the corresponding message will be displayed. Regarding transactions, they are mapped to PSTart transaction or PSEnd transaction. The first approach, and if a dataset is in cached update mode, apply updates, commit updates, or cancel updates are called correspondingly. Before we go further, I'd like to consider more interesting cases. How local SQL is used. I'll use the RAD application. The first I'd like to show is how to work with text files or comma separated data in files. In this application, I'll use the event on get dataset. This event allows to change the dataset ad hoc and allows to create the dataset dynamically and manipulate with them. Let's see what we have there. The dataset name is a name, and in this case we'll create a table in memory, and then we create a data move component. It is linked to a table in memory, and the data source is type of text. The name of the file is also set, composed. I'm using files which are provided with the FireDAC library as demo files, and then I use the following interesting capability of FireDAC. We can analyze the structure of the text file, and the data set is automatically configured to accept these data. In our case, the structure is automatically defined and the table is structured properly. Then everything is executed of the data loading in the mem table component. Then the component property name is getting the proper name, and the component is then returned to the local SQL. A pair of words, what we have in the beginning. You can see that the component is dynamically created, and the owner is our local SQL. And in the beginning we see if there is such a component, and it is a table in memory, it is returned. If it is not found, we have the process of creating a new one. The application itself is quite simple and trivial FireMonkey application, which uses live data, live bindings mechanism, and everything, and the rest components are already explained. The database in memory, the local SQL component, then query, which will be executed and will AD query, which will execute the local SQL command according to the text of query, and the result will be displayed in the grid. Let's run the application and see what will we have. As the table territories is not available, we are having the internal exception, which will be caught in the event on get dataset, and then the next table region is also created. The data are loaded from the files, and the data sets are then passed to the local SQL and the queries are executed. Then I'd like to show you the heterogeneous queries, so I'm using the SQLite database from demo and Microsoft Access database from the corresponding demo provided with FireDAC. And I was using the so-called connection definitions as schemas for my data structures. These parameters were stored for connection. What will I do next? First, I'm decoding the table name. So I have the name of the table and the name of the schema. Then I compare the name of the schema with the names of the available components. If the corresponding component is not available, I'm creating it and I'm setting its name. Here you can see setting of the name, and then I'm setting the schema as the connection name, so we can use some arbitrary available connection for this operation. And then finally I can set the query name as to select all the records from the given table. So the application is up and running. We get 2 predictable exceptions, and finally the data are retrieved from tables and exposed via GREET component. And finally, I'd like to show how local SQL engine and FireDAC can work, can communicate with data sets not from FireDAC by some any arbitrary dataset components. I will use client dataset and I'll use ADO components and data from Microsoft Access accordingly. In order to use all the power of local SQL engine, I need to register the dataset components, and I'm adding them to the local SQL components and assign names for them. Then the names will be used to address the proper datasets from inside the local SQL engine. Very important point is how to properly set the adapters. Adapter is a class that implements a specific local SQL interface. In other words, this class helps communicating between local SQL and dataset. In particular, it allows setting ranges using save points or calling index of names. Here you can see two classes, first for client dataset and second for add or query. In future, these links between adapters and the components will be done automatically, and truly speaking it is already on the way. So in the nearest RAD Studio releases you'll find such functionality, but now it should be set manually in code. Okay, now let's run the application and see how it works. In this case, no exception happens because we have registered datasets in advance. The query have executed successfully, and in the end I'd like to tell some words about the namespace and schemas. TFD LocalSQL component has a schema name property to set the schema name. How will you use schema names? It's up to you. You can group these schemes logically, organize them in groups. You may use connection definition names to store the connection parameters. In order to use some schemes, you need to use some components TFT LocalSQL and use different schema names. The names should be unique. Then in SQL commands you can address using dataset names or using the full name schema.dataset. If the dataset is not registered, you'll need to use the onGetDataset event to use the dataset on the fly. And then some words about new coming features. First is the single FD LocalSQL for many schemas. Then, as I said before, automatic linking of adapter and FireDAC datasets with no manual techniques and coding, no code for linking these components. Lifecycle management will be better for dynamic dataset sources, namely for example, this code will pass away. You will need only to write the logical code, not the service code. The control of cached updates will be better. You will have the two-stage mode for cached updates, and finally the query execution will be faster, as LocalSQL will be closer to SQLite built-in query optimizer. So we can conclude that the further evolution of this technology will make you a bit faster in your applications. And you'll need less coding, many things will be done automatically. Everything I've told about today can be found in documentation for RAD Studio, and please find more details there. And now I'm ready for questions. Question number one is about languages other than English for FireDAC documentations. The answer is that documentation is available in English, German, French, and Japanese. Other languages are considered as some maybe, but not now. The question about mem table in FireDAC versus client dataset. These two components have nothing in common in implementation, but functionally at the level of the end user API they are similar. They solve similar problems. In many cases, client dataset can be replaced with FD mem table with no extra work for recoding because the functionality is just the same. So generally speaking, if client dataset is used as the in-memory dataset, it can be replaced with mem table. But regarding the MIDAS or data snap, MIDAS or data snap functionality is unique, but we have made a first step towards the use of FireDAC in this multi-tier technology. So TFD stored procs can be used to access data in this multi-tier architecture. At the moment we are trying to integrate FireDAC into data snap, not integrate but use together in the same architectural in the same architecture, but please wait for the results in the future. But if we are making a technical comparison between client dataset and mem table in FireDAC first provides better performance. Second, mem table provides more services. For example, you can find records not only by values of in fields, but using some expressions. That's very convenient. And maybe third, mem table is a part of FireDAC and FireDAC infrastructure. So in view of the topic of the webinar, I can say that mem table is closer integrated with the local SQL engine in FireDAC. So there are some much convenience in using mem table with the FireDAC components, but there are some other advantages, but I guess it's enough for the moment. The question how local SQL works. Once again, local SQLite is the embedded database engine, and it can be fully integrated with the host application. What does it mean? It means that you can replace or plug in some standard SQLite mechanisms and use another. For example, change some file system or change the replace the data set, as I have done for local SQL and FireDAC. So SQLite engine works as it does with its own data sets, but instead its data sets it uses FireDAC data sets, but with the same mechanisms and with the same SQLite engine. But if you want to understand all through, you should refer to the documentation on SQLite. Yes, I replace the SQLite table for my data set, and in documentation all this mechanism is well described, and you can find in details how it works. Another question is regarding the append call. So in code you could see the adding records with append method. So how it works? Let me please explain. This is not a FireDAC specific method. No, it's append record is a method of T data set. Nothing special in FireDAC. This method append record can be used with any data set. So in fact, first append is called, then values are assigned to the fields, and then everything is submitted. But if you have no experience with mem table, it's easy to define the structure of the table in memory, then call the create method to create this data structure as a table, and then add as many records as you wish. Maybe the last question to compare the convenience of FD table versus some vector or no relational data structure. What is faster? I don't think that FD table provides the best performance, ultimate performance, but it is very convenient if you need not only to keep the data in memory, but if you need some search, some find, filter data, or to persist data, save data on the disk and perform some relational operations. So in this case, memtable is a very good choice. Yes, and please once again keep in mind that it's a part of FireDAC, and infrastructure is ready, and it's very convenient in using memtables with local SQL, but not limited to. Thank you for your attention, and welcome to another questions online in the comments.